We all hear about the trend to convert passenger cars and commercial trucks to electric vehicles, but not nearly as much about tackling CO2 emissions in the built environment, especially commercial buildings. What are their contribution to global CO2 emissions? But how can commercial construction companies and property owners reduce this carbon footprint and offer their tenants both a pathway to net zero and a better working environment for their employees? A solution that's gaining traction is direct air capture technology, integrated into the HVAC systems in buildings. Petri Laakso is CEO of Soletair Power, which is rolling out these solutions around the world. Stay tuned. Petri will join us from Soletair's headquarters in Finland in just a moment. Inside ESG is a timely new production which takes you inside the work of practitioners on the ground, chief risk officers, market analysts, cybersecurity experts, and founders of game-changing startups. We'll talk with specialists in every corner of the globe, across industries and issues, dropping into Argentina to hear about lithium mining, Central Asia for a view of China's Belt and Road Initiative, and West Africa for a perspective on climate risk, among other stops. Hi, Petri. Nice to see you again.
Hi, Maureen. Thanks for having me on the show.
So your company, Soletair Power, provides technology for direct air capture of CO2. What is direct air capture?
Well, direct air capture, that's a technical method to remove the CO2 from the air. And since the climate change is happening because of CO2, that's one of the technologies to kind of turn back the climate change.
What's the role, could you tell us, of carbon capture in general for reaching emissions reduction targets around the world?
Yeah, maybe we need to kind of distinguish two different things. Let's say the traditional carbon capture, when we limit the emissions. For example, if you have a power plant and you're burning coal, you are producing a lot of CO2 emissions. That's the kind of the point source capture, and then you're limiting the CO2 going into the atmosphere. That's a kind of a different kind of a CO2 capture, and that's like an established technology, and the cost level is somewhat low. Then what we are doing is that we are capturing CO2 directly from the air, and that removal is something what we need to turn back the climate change. So remove the excess CO2 from the air, and then, of course, permanently remove it by mineralization. So these two things we need to kind of distinguish when we speak about carbon capture.
So when you say permanently remove it through mineralization, are you meaning to capture it within concrete products?
Yeah, mineralization is one of the how we think that you should utilize the CO2 to make negative emissions, because when CO2 is forming with calcium oxide, the calcium carbonate, it's a kind of chemical compound that basically never turns back into the atmosphere as a CO2.
How big of an impact can tackling this problem of building-based emissions have? There's both, constructing buildings and then their operation. And I believe it's a rather large percentage of global greenhouse gas emissions that you'd be going after with this solution.
Yeah, actually, it was a big surprise to me when I joined this industry that buildings are related to 38% of global CO2 emissions. So it's a huge part, and mainly the 38% of emissions is because of in buildings we need to have lights on, we need to heat, cool, ventilate, and so the operational emissions out of that 38 is the 30, and 8 is the construction of buildings. So we should reduce the energy consumption in buildings as much as possible. But the challenge, of course, is that if you want to be net zero, you cannot do that by reducing, because basically you need to stop utilizing the energy. And that's why we need negative emissions in order to kind of make buildings as carbon sinks. And net zero building basically happens when you use renewables to run all the operations of the buildings. So maybe it's a wind power, hydro, or something like that. And then you compensate the emission coming from those electrical production methods. And this way you go to net zero. But if you want to change the climate change, we need to go to net negative, which needs the negative emissions. And of course, there are nature-based solutions also available to do that. But then the duration of the emission offset is also one thing. That forestry-based is typically like some tens of years, and we can do like a basically infinite amount of years if it's a mineralization.
So what's different about Soletair Power's solution from what else is available?
I'm not sure, are we the only technological means to create negative emissions in buildings? But at least in the direct air capture space, there are several other companies in the world. I think we are closing to 100 startups. We've done 6 commercial installations, but we focus solely basically in the CO2 capture in buildings. And why do we do this in buildings is because you need to ventilate huge amounts of air in order to capture a lot of CO2. And if you think about the places in the world where the air is being kind of ventilated, so in buildings that happen, and it's like a distributed capture. So I think this is a good way to do it within buildings. Other companies are focusing on large outdoor scale capture somewhere far out. But we can benefit the building owners because you can lower down the fresh air rate, save energy at the same time, so reducing energy consumption and saving costs, of course, because you are not using so much energy anymore. And while we also deliver the negative emissions, that's a huge value for the building owners because everybody wants to be net zero sometime in the future. So several benefits with our solution, and we think that this is the most economical solution to do the direct air capture at the moment.
You know, previously you mentioned to me, so we've been talking about the benefits from, approaching net zero or negative emissions, but also in terms of removing CO2 from the air of commercial buildings, there's definitely a health benefit to people who work in them, isn't there?
Yeah, there are scientific studies about that if the CO2 levels can be kept at, let's say, close to outdoor conditions, there's a distinctive difference on people's cognitive performance if the CO2 levels would be high within the buildings. So that's basically the health benefit, of course, that if we can. Everybody knows this, that if there's a meeting room full of people and of course people are exhaling the CO2, there might be a little bit of stuffy air. That is something what we can also remove. So that's also the, let's say, the health benefit side. But there's a difficulty to put the value in that, how to measure that. That's the challenge nowadays. So that's why we kind of speak the energy savings and cost savings within the buildings. But the health benefits are, of course, there too.
Right. Even if it's tough to quantify, I do think that, especially post-pandemic, with people not being overly excited about coming back to work in an office building all the time, whatever companies can do to make the space more enjoyable, and more a place where their well-being is supported, I think it has a lot of value.
That's right. I saw one article from Harvard Business Review, and the number one thing listed by the employees was the good indoor air. So that's why if we can improve the indoor air further than what it was, that's of course something that what people want also. And one thing also what people value is and companies is that if the building is net zero. Many companies want to be net zero in their operations. Now they are claiming the building owners, because they are tenants, they want the building owner to be also net zero so that they can kind of claim that all of their operations are net zero. So that's the kind of the why building owners should do these kind of things.
Right. Now, you'd mentioned a moment ago some of your installations.
Yeah, we've done, like I said, 6 commercial systems, and they've been completely different kinds. But nowadays we focus basically on the building HVAC, so building mechanical ventilation connected CO2 capture devices. 2017 there was the pilot from our co-founders' idea. It was delivered. It was an outdoor capture. But then 2020 we delivered a system for the Dubai World Expo. It was about capturing CO2 from air, turning water into hydrogen, and synthesizing CO2 and hydrogen into synthetic natural gas, which we burned on site with the coffee machine to heat up the water for the coffee and tea. So it was kind of a demonstrator that we can deliver a system wherever in the world and operate it remotely. Then we delivered one outdoor unit to Germany. Same CO2 capture technology, just containerized and taken to Germany, outdoor capture. Since then, we've done a couple of cases here in Finland for building ventilation connected. One is in Vaasa. It captures the CO2 and makes the energy savings benefits for the building owner. Second one is close to Helsinki. It's a factory system that makes raw material for the factory, so that the customer can utilize the CO2 on their operations. And the next case, what we are doing is that we are turning one office building into a carbon sink in Denmark this year. So that's something what we've been doing, and I think it validates the technology that it really works.
What are they reporting back to you in terms of the ease of use of the device?
Well, the ease of use is basically it's a fully automatic system. So it runs together with the building ventilation system. You don't need any people during, let's say, daily routines or anything like that. There's a once or twice a year a maintenance, a really simple task for 1 hour or so, and that's about it. So because there's no mechanically moving parts inside the system, you could see it as a filter. And since it taps into the building heating system, so we utilize the heating energy from the building, it works also alongside with the building. And then it depends also that wherever in the world we are, we can utilize the heating infrastructure. For example, in Vaasa and in the Danish case, we are utilizing the heat pump on the building to create the heat for our system. So we can kind of utilize less grid energy because we can have the coefficient gain of the heat pump.
Well, it sounds like you're already experiencing quite a bit of growth in demand and plans for installations. So what's the potential market look like for your product?
Yeah, of course, as a startup CEO, the plans are really, really bold. So we see that all the buildings in the world which have mechanical ventilation basically are our target market. In a single high-rise office building, you may have tens of units already, because we go ventilation unit at a time. Denmark, for example, is putting really stringent kind of levels for CO2 emissions, and engineering companies there are saying to us that our solution in buildings is basically the only and cheap way to address those limits. And when this kind of regulation goes wider, like there's in New York also a local law 97, for example. So this kind of regulation will kind of favor solutions like ours. So that also kind of, how do I say, gives a tailwind for the solution to kind of have a wider deployment.
How did this all get started? How did the company get into direct air capture?
Yeah, this is an interesting story, and actually there's a YouTube video or also on our YouTube page. But it started 2016. Mr. Piispanen, co-founder of this company, saw on a local newspaper that the local university professors were in Germany. They were looking on that picture at a point source. There was like a combined heat and power system plant that produces heat and electricity. And there's a smokestack, and the professors were thinking on the newspaper that they would buy such a system and start creating fuels from that CO2. And then Mr. Piispanen called them that, hey, why do you want to take it from the point source? Because there's plenty of CO2 in the air. And the professor said to him that there's no equipment that they can buy, so it's difficult. And that's what happened the next year, the delivery of the pilot unit. And that was kind of the starting point for this company. But then 2017, we kind of pivoted away from the outdoor capture to the build. And if you think about different parts of the world, for example, here in Finland, in the wintertime, it might be minus 30 degrees Celsius. Everything will freeze out. If you go to Dubai, or let's say in Miami in US, in the summer, it's going to be really hot. And the performances direct air capture systems might be compromised. But in buildings, it's going to be really, how would I say, high stability environment, plus 20 degrees Celsius, and the air is clean. There's no sandstorms inside the building. So that's why we kind of pivoted into buildings and building ventilation.
What can you tell us about the cost of the units and the efficiency and, what you're targeting that to be in the future?
Yeah, I used to be in the solar industry previously, and solar industry has seen a tremendous cut of costs over the last 20, 30 years. And I see direct air capture in pretty similar situation like the solar was in the 1990s. Currently, our system is roughly a bit more than a 10-year payback if we sell a unit as a one-off item on typical installations. But our target is to sell this as a service so that when the customer is saving money while they are not using so much energy, they can spend that money paying us so that we can make the building acting as a carbon sink. And the target year for that is like 2030. So I think that gives a little bit of flexibility on the on what's the cost and how we see how it's going to be in the future.
Well, Petri, I wanted to thank you for being on the show today. It's been very interesting, and I look forward to hearing more updates about Soletair Power.
Yeah, thanks for having me, and it's been my pleasure.
Thanks for joining us today. To make sure you don't miss out on our next episode, subscribe to the Inside ESG podcast on Spotify or any podcast platform, the YouTube channel, the LinkedIn newsletter, and our mailing list on InsideESG.com. See you next time.